Greetings, sir. We are here to present our cloud computing project to you titled as Deploying a Voting App on AWS Kubernetes. This is our team, Surya, Yashant, and myself, Pranav. Let me give you an overview of our project. We are deploying a three-tier complex cloud native application on Kubernetes. This is a voting application which has front-end as React, Golang as API, and MongoDB as database. Whenever user votes, this data gets updated in the Mongo database. Let's move on to the details of the project. This is the architecture diagram. As you can see, the application is deployed on Kubernetes. So we will be using Amazon AKS to deploy the application. In this application, we have three things: front-end API and database MongoDB. We'll start with MongoDB. So it has three pods: pod 0, pod 1 and pod 2, and they are going to be deployed using stateful set. We have three pods to enable replica sets in MongoDB, where the first pod is going to be primary, pod 1 and pod 2 are going to be secondary, which are going to be having replicas of the data but will only work when first pod is deleted or destroyed. Along with pods, we have PVS, persistent volumes, and PVCs, persistent volume claims, to store the data from database into EBS volumes in AWS. So we'll be creating EBS volumes as well. So next we have API. It is going to be deployed using deployments, and it has two pods. This API is created in Golang and exposed using a service of load balancer type. So how do the API get the data? It comes from the front end. It is going to be deployed using deployments. We are going to have two pods in front end. So the front end is in React, as you already know, and it is exposed to a service of load balancer type, and that's what our application is. So this is our technical stack of our project. Let's move on to the technical details of our project.
This is N Yashwant, 21BDS043. I'll be continuing from here. We'll start by creating the cluster. We'll look into the configurations. Now we give it the name cluster1. We set up the Kubernetes version as 1.28, and then we assign the my Amazon EKS cluster role. Further details is given in the GitHub repository. Now we set up the default VPC, subnet, and security groups. Now we look into the add-ons that we give for the cluster. The further details are given in the PPT. These are the add-on settings. We review and create the cluster. Now we'll add an extra add-on, that is Amazon EBS CSA driver. Now we launch an instance. We name it Cloud Project Server. We select the Amazon Linux. We give the T2 micro instance type. We created a new key pair, Surya. We give the EKS access role. We launch the instance. Here we successfully launched the instance. Now we'll connect the instance. Now we'll install kubectl using the Kubernetes documentation. Here we could verify the installation of kubectl. Now we'll install the AWS CLI using the AWS CLI documentation. When the cluster is active, we create a node. We name it as node group. We declare my Amazon node role. Then we choose the instance type as T2 medium. We declare the disk size as 10 GB. We review and create the node group. Here the node group instances can be seen of type T2 medium. Now we name it node 1 and node 2. We could see the allocated 10 GB of size. Now we set up the context. Here we could see the context being added. Now we'll configure the AWS by using access key ID secret access key. We declare the region name as AP South 1 and format as JSON. Now we can see the nodes running. We import the files into the terminal. These details are given in the GitHub repository.
Creating a MongoDB database. First, we are going to apply the mongo stateful set.yaml file using this command. We can see here that 3 Mongo pods get created and also 3 PVs are created with each 1 GB of storage and 3 PVCs also get created. Now we will apply the mongo service.yaml file. This will create a mongo service which we can see by kubectl get svc command. Here we can see 3 mongo pods are created. Now we are going to create this MongoDB architecture in which 1 primary and 2 secondary nodes are present. We will assign Mongo 0 pod as primary, Mongo 1 and Mongo 2 pods as secondary using this command. Using langdb, we will give the information about the web application to the Mongo database, that is about different computer languages.
This is Hurtin Surya Kotni, 21BDS031. I will be handling from here. If you open the mongo secret.yaml file, you can see that username and password in something different codedly. But this is in B64 format. So every secret that we create in Kubernetes will be in base 64, and to confirm that, here I gave you one link. If you go to this link and you paste these username and password, after decoding you can see that it was showing that admin and password. Now we will apply the secret.yaml file. After that we will deploy the Golang API using deployments. After we successfully created the development of APIs, we can check it using kubectl get pods. There you can see that 2 API replicas are formed and 3 Mongo pods are formed. Now we will expose the API development through load balancer service. This code here will give you an OK message after completing the creating of load balancer. Now let's test this API. By copying the link and pasting in a new tab, it will after /OK, you can see an OK is presented here. If we replace the OK with languages, we will get the languages which are in there in the MongoDB. We can also get any specific language like Python here. First we will deploy the frontend deployment.yaml file. After successfully deploying it, we will check whether the 2 replicas of the frontend are created or not by this command. Here we can see that 2 APIs and 2 frontend and 3 Mongo pods are created. So we can verify that the frontend replicas are also in ready state here. In this command you can see that the two services of API and Mongo are ready, and deployment of apps API and frontend are ready, replicas of API and front are ready. So stateful set of apps and Mongo 3 pods are ready. So now we will expose this frontend deployed pods. We use load balancer to expose this front-end deployment. We can see here successfully our front-end is exposed. Now if we say kubectl get svc, we can see here our API service, which is a type of load balancer, is available. Front-end, which is a load balancer type, is also available. We can also see there is a cluster API. Mongo, which is a type of cluster, is also ready. We have successfully deployed the front-end pods, but the load balancer takes some time, so this command will say when it is ready. Here we can see that the load balancer is ready, so we copy this link here and we'll paste in the new tab. It will launch our web app here. Yeah, we can successfully launch. So let's try by giving votes for JavaScript. Let's give 6 votes, and for Python give 9 votes, and for Golang we will give 10 votes. And now let's see it in our database. Here you can see that Golang 10 votes, JavaScript 6 votes, and 9 votes for Python.
We really appreciate your help and guidance throughout the preparation and presentation, sir. Thank you so much for your insights.